Hi, I'm Chris Hogue, and in this video we're going to learn how to open and save data in R. So let's get started. First of all, let me tell you a little bit about the data we're going to look at. The data is from a series of protein structures, and what I'm showing you right here is the folded version of a protein called the villain headpiece. And notice it's a nice compact three-dimensional structure. So I have a series of proteins that are very close in shape to this protein, and I also have a series of proteins that are in random unfolded conformations. So these are random conformations of the same protein. As you can see flip through some of them here. And so that represents another set of data. So I have two sets of data that I'm going to analyze in the R language. One set of data looks like a bunch of proteins that are very close to the real fold of the protein, and the other set looks like a bunch of proteins that are in random orientations. So there on my desktop here I have two data files, near, native, and random, and those data files have been edited in the Excel package. And one of the issues that people often have when they want to start doing statistical analysis in R is that they've already tried to do some work in Excel. Here's an Excel spreadsheet with my my data in it. Let me just increase the font size here so you can see it a little bit better, and increase the table sizes so you can see the headers. So this is a data set that corresponds to a series of structures that have been generated that are random in size, and there are 100 rows in this spreadsheet. And the parameters at the top, this is essentially a table of data, are headers that will correspond to different measurements that we've taken from each one of these different three-dimensional structures. You can see at the end here there's a value called the root mean squared deviation, and that's the measure of how close each random structure is to the native structure. And these numbers are quite large, and of course a perfect RMSD is 0. So if the two structures are exactly the same, the value will be 0. These numbers are quite large, meaning the structures are random, they're unfolded, and they're quite far away from the native structure. We also have 4 energy terms here that I'll talk a bit more about when we go into graphing. So that's what the data looks like. Now, a couple of other things about this spreadsheet. The spreadsheet has no formula. This data was actually imported from another piece of software into this spreadsheet, and none of these columns contains any calculations. So one of the aspects of the R language is it can't read an Excel spreadsheet that has formulas in it. It can only read tables of data. So in order to get data from an Excel spreadsheet or any other file into R, you have to make sure that the file doesn't have any formulas and that it's in one of a series of acceptable file formats for the R package to use. Now fortunately the Excel package has a way of saving as, so I'm going to pick Save As here, and I'm going to save this file and replace the file random, which is a comma separated value file, or comma delimited. That means if you open the file and look at it, there's a comma in between every value in the table. So Excel supports the export of a CSV or comma delimited file, and we're going to save this file as a comma delimited file. And I'm just going to replace that since I've already made it. And it will come up with a warning that says that the comma separated value file is not compatible with Excel, but we're just going to keep that anyway, and I'll close Excel. So what I have here on my desktop are a couple of files: a near native file, which are protein structures that are close to the true folded protein, and a random file, which are a bunch of structures that are far away from the true fold of the protein. So next let's move on and open up R. I've got my R graphical user interface here in my console. And let's start learning how to load information into R. Now, if you're familiar with regular software, R tries to use a command line for many operations, but it does have a graphical user interface, and there are, in fact, menu items that allow you to open and save things. So one of the ways that you can open and save things is to load and save the workspace, which saves all of the objects that you might have created in an R session. So you can save the workspace and load it later. And when you use these file operations, load, save workspace, or save workspace, they actually will print out R commands on the command line. So if I click on File, Save Workspace, it'll ask me to pick a file, and I can just say test workspace, and it saves it as a .rdata file. And you'll notice it actually, that file command actually printed out a command in the console that says save.image with the file name c:/users user documents test workspace. So when you're using the menus, you'll actually see the command being printed in the R console that's being operated on. So in that image that I just saved, there was no objects in it, so I'm sure there's nothing much in it. But if you're interested to find out what's in your R system, you can use a simple command, which is ls with 2 brackets. Now that's a function in R that lists all the objects, and it returns character bracket 0, and that indicates that there's no objects currently in the R workspace. One of the things is if you type a function name without the brackets, it looks like this. If I type ls, it'll actually report a function and a whole bunch of code, and you might not know what's going on. That means when you type the name of the function, it actually lists the function. But to call the function, to get it to work, you have to use ls in a bracket. Okay, so we're going to call some functions to open up some of the data that we've seen. So I've got 2 files. One's called native, and one's called, near native, and the other one's called random. And I'm going to open those up. And I can do that from the command line. But first I have to understand where those files are on my system. So one of the commands you can use in R to get your working directory is the get wd command, which gets the working directory. And it says c:/users user documents. I actually want it to get the file off my desktop, set wd. And I type in the directory location, which was c:/users/user/desktop. And now that has changed my working directory, and I can see what my working directory is again by using the get working directory command again. And so now I've changed the directory to desktop. If I want to see what files are on my desktop, I can use the R command list.files. And that lists 3 files. One is nearnative.csv. That's the comma-separated value file that we saved from Excel, and random.csv. So I have 2 data files on my desktop, and I'm ready to load those into R. Okay, so a couple of things before I load those in. I want to show you a couple of help functions. I've showed you a couple of functions now: get working directory, set working directory, and list.files. If you want to get to help in R, you can type question mark and the name of the command. So you can type question mark get wd without the brackets, and that's going to launch the help server, which is get or set working directory. So that comes up in an HTML browser, and that's automatically launched from the R system. So this has information about the arguments that each command takes and what it returns. So here's examples. Working directory is given the value of get working directory, and if it's null, then it's been used to set a different value. So examples for most commands are at the bottom of those help files. So if you don't understand how to call a command, scroll down to the bottom of one of those commands. So we can do the same thing with list files, and that will go to the web page that has the instructions for list files. List files can take paths, it can take patterns, regular expressions, and you can use information like this to list files and directories. So commands can be understood by using the help features that includes the question mark. Another feature that you can use to get help from the R system online is if you want to search through the help pages, you can use a command called help.search. So if I want to search through the help, that is, for anything that includes the term dir for directory, I can type in help.search, and it will search through the help files and give us a bunch of information about commands like get working directory, directory create, how to set environment variables, and a few other functions, including choose.dir, which allows you to choose a folder interactively. So those are a couple of different ways to search the help file. If you know the name of the command, type question mark on the name of the command. If you don't know the name of the command, you can use help.search together with the name that you, the word that you want to search for in brackets enclosed in quotation marks. So that's how to get help for some of the functions. So we're back to loading in data into R, and I've got two CSV files, which we can see with the list files command. I'm just going to execute that again so I can see my file list. So I have nearnative.csv and random.csv. Now these files come from Excel. They're not native R data files. Now let me point out to you again that the file command, the pull-down menu in R has load workspace and save workspace, which saves the objects there, but it won't load from the menus files that you make from Excel, like these .csv files. So in order to load those in, there is a command called read.csv. And read.csv, we can put our question mark in front of it and read about it in the help. Read.csv, here comes our help, is a data input file, and it's a variant of a bigger function called read.table. Read.table is a rather large function. Read.csv has a bunch of default values that include separators. This here, that's the separator, which is a comma, because this is a comma-separated value file. So in order to use read.csv to read in this CSV file, we use the command read.csv file equals random.csv, and the parameter header equals true. So that passes a logical value to the command read.csv to tell it that there is a header, or if you remember the Excel file, we had titles for each names of the rows. So random.csv is a simple table of numbers. There's 100 values in the table, and it has a whole bunch of headings. I think there's about 16 headings in this table. And I'm going to assign what is read in to a variable using the assignment operator, and the assignment operator is an arrow formed with a dash and a greater than symbol if you want the assignment to go from left to right, or a less than symbol and a dash if you want it to go from right to left. So the assignment, I want read.csv to be assigned to a new variable, which I'm going to use, called random, which is the same name of the file, so I remember what it is. So that's going to read in the file random.csv and assign it to a variable called random. So now I have a thing on my desktop called random, and I know that because I can type in the ls command with brackets, and I have one object called random. So what is inside random? We can query random with a couple of standard S functions to find out what type of variable it is, because a variable could hold a simple number, it could hold a vector, a matrix, or a whole bunch of different columns in a table. So there's a function called class, and class of random tells us what type of object it is, and it's what we call a data.frame, or what's commonly referred to as a frame in R. So this object random is of type frame, and that means it's actually a complex data type already. If we want to understand what the headings are in this file, we can use a command called str, which tells us about the structure of this object. So str is a short form for structure, and if we type str of random, so here's what the structure of random returns. We see we have a data frame with 100 observations of 18 variables. Now this table is still stored in columns, just as it was in the Excel spreadsheet, and what it shows you here is a row representing the first few variables and their values in each one of the columns. So in this case, each row now corresponds to each column that was in the spreadsheet, and this gives you an indication that the first 4 rows or columns in the table are integers. Then the next few are floating point numbers. There's a few more integer values, and the other ones are floating point numbers. So R is able to automatically read the information in this CSV file and assign it to columns of the appropriate type of number. So this is a fairly complex piece of data that we've just loaded into R, and it's stored it into a data frame. And we can find other information about the data frame using a command called dim, or give it the dimensions. So dim will tell us the dimensions of this object random. And it's 100 by 18, so it's 100 rows and 18 columns wide. So that's how we read a CSV file into the R package. Once we have an object listed, if we see our objects, we've got random, we can load in the other data set that I have with the same read.csv file. So I can read.csv. The other file was called near native, and header equals true. Is that uppercase? True. And I'm going to assign that to an object called near native. And no such file or directory. Oh, yes, it's nearnative.csv, of course. So if you have trouble like I do sometimes remembering file names, there's another neat trick that R has where you can interactively open up a dialog box instead of having to remember how to type things in and forgetting extensions like that. And so the command choose files, or file choose rather, allows you to interactively read in that file. So if I remove with the command rm, I can remove near native. I'm going to load it in again with read.csv. But what I'm going to use inside read.csv instead of typing the file name is I'm going to use another command which is called file.choose, and I'm just going to run file.choose right now by itself. And file.choose actually opens up a dialog box, and if I go to my desktop I can see near native and I can open it up. And you'll see what file.choose does is it gives you an interactive display of your desktop browser, and in return it gives you a path to the absolute file name with the .csv in it. So that's kind of neat. So I'm going to use file.choose inside the read.csv command like this. Read.csv. And instead of typing the file name, I'm going to type file.choose. It's a function, so I have to use its brackets as well. And then I'm going to type in header equals true. And I'm going to assign that to, with the assignment operator, to near native. Now this time when I load in, or when I run read.csv, it's going to prompt me with a handy dialog box, and I can go and click on near native. I can click open, and that will pass the file name to the read.csv function, and now I should have an object called near native. So let's take a look. I'll use the list command, and now I have two objects. One's called near native and one's called random. If I want to understand more about near native, I can use those other commands that I showed you, like class near native, and that's a data frame. So I know in a data frame I can look at its dimensions. The dimensions of near native, it's 200 observations of 16 variables. It's slightly different from random. What else can we do? Class dimension, oh yeah, there's one called head, which I didn't show you. Head of near native shows you the top about 7 or 8 lines of the file, so that's what it looks like, and that actually looks like what we saw in the data table for the Excel spreadsheet. There's also a command called tail near native if you want to see the last few values, and we can see that the last few values end up with a number 200, so there's 200 rows in this table. So that's head and tail. And there's also that command I showed you before, the structure str of near native, and that tells us about the headings. Again, these are the headings. There's 16 variables in here. There's a few that are different between these two files, and so if I look at the structure of random, it has a few extra columns. This one, helical and extended, and those are columns that aren't in the near native file. That's because they didn't vary in the near native file. They were always constant. So the tables are slightly different, but mostly they have the same type of information. So a few other things before we finish off this section on loading and saving. Remember that I have two objects now in memory, which are complex data frames that I've loaded in, which originally started off as Excel spreadsheets, saved as CSV files, and then read in as data frames. And where I want to go to next is just to tell you that you can save those objects as they are existing in the R workspace using a command that's called save. So if I save those objects, I have to specify a file. So I have to give it a file name, and I have to use file equals my stuff .r data. So that's going to save it into a .r data file, which is a recognized file type for our information. So when you save information, if you want to save where you are, you can do it a couple of different ways. One is to use File, Save Workspace on the menu. The other is to save information using the Save command. If you use the File menu and Save Workspace, you can save everything. If you just want to save one object, you can use the Save command, and I've got a save file equals mystuff.r data, and I have to put a list in of the objects that I want to save. And in this case, I want to save the object random. So that makes a file with just the information from random in it. And if I want to load that back in, I can use I can remove the random object, which again is that table. If I look at what I have, I just got near native now. If I want to load random back in as an already parsed R object, I can use the command load file equals my stuff .r data, and if I list what I have now, random comes back. So you can save an individual object in R using the save command. If you want to save your whole workspace, you can use the file command. I'm going to use that file command and hit save workspace, and I'm going to type a file name my workspace, and it's going to save it as a .r data file. And notice again it used the save.image and the name of the file that I typed in. So save.image saves everything in your file system. A couple of other things about objects in R: if you need to delete them all, you can use the command remove all objects, and remove all objects says are you sure? And it uses the command remove, and you saw me use the command to remove random. I typed in one name of one object. To remove all files, the remove command has a parameter in it that is list ls all equals 2. So the command inside the wrapper of the brackets ls all equals true lists all the objects, and fortunately there are none at the moment, so I can create an object. X gets 4.5, Y gets 5.6, Z equals X to the power of Y. What is Z? It's an interesting number. So you just found out how to do exponents to an arbitrary base. So now I have the objects X, Y, and Z in my workspace, and if I list all equals true, that gives me a list of all those objects as well. So to remove that list, remove list equals ls all equals true, returns a list of all the objects in the workspace, and that creates a vector of objects X, Y, and Z, which are passed to the remove command, and it deletes them all. So now when I do list, I've cleared out my workspace. So we've gone over how to import data from Excel using a CSV file. We've gone over how to inspect data with the str command to look at the structure of an object. We've looked at the class of an object, and we understand a bit about a data frame, that it's a complex object, in this case with columns of data from various observations. And we've also looked at how to save and load object as native R files using the save and load commands or the menu. So to wrap up this video, we have learned how to open and save data in R. And the next video in this series is going to be simple graphs in R. We're going to use the same data sets that we've loaded in and show you how to make some simple graphs and look at some of the distributions of the data in these structural data sets. Thank you, and see you in the next video.